Okay, so we're recording. So we're going over number 60 in the chapter 6 review. In fact, actually, I can tell you what page number it is. I believe it's on the newer edition. Give me one sec here. Yeah, it's page 327. We're gonna do number 60. So I'm not saying it's for homework, but you're gonna have a homework problem close to this one. And it's just like the last example we did in the 6.4 notes. So this is the graph of f, just so you know. So this is f. If it helps, you can write f here. And of course, that's x. And g equals the integral of f. So what this tells me is that g prime is going to equal f, and g double prime is going to equal f prime. You kind of want to get that out of the way quickly, because if I were to take the derivative of the left side here, which is g prime, and take the derivative of the right side, which is derivative of an integral, you get f of x. Remember, that's FTC, part 1. And if I do the derivative again of g prime, then they get g double prime, and you get f prime. So that's what's going on. Okay. So you're asked to compute a few things. You're asked to find g of 4. So remember, g of 4 is going to integral from 1 to 4 of f of t dt. So that's just going to be area from x equals 1 to x equals 4. Also being asked to find g of negative 2. So you get to integrate from 1 to negative 2 of f of t dt. So you may want to actually reverse the integration, just so you know. Go from negative 2 to 1, and there's a negative right there, of f of t dt, and then find that area from negative 2 to 1. So it's going to equal the negative area from x equals negative 2 to x equals 1. So that's all part A. Find this case rate of change of g. So you want g prime of 2, which equals f of 2. So you'll find f of 2. For part C, find absolute minimum on the closed interval from negative 2 to 4. So you'll need to do there, easily make a table. You got, and remember, this is for g of x. So you're going to plug in negative 2 and 4. You already know what g of 4 is anyway, because you did that in part A. And g of negative 2 should be pretty obvious because you got it from part A as well. Then you got to find your critical points. Your critical points is when g prime equals 0 or f equals 0. So I'll let you guys figure that out, and then plug in into g and see which one is lowest. And then for part D, the second derivative of g is not defined x equals 1 and 2. That's because you got corners there, because f prime. Let me get it red here. Remember, g double prime equals f prime. And f prime does not exist at x equals 1 and 2 because you got sharp corners there on the graph of f. So then which of these values are x coordinates of points of inflection? So you have to tell me which ones are going to be points of inflection. And remember, that's when g double prime changes sign or f prime changes sign. Okay, so I'll give you guys about 10 minutes to work through this. If you feel like you have all the answers, or if you want to share some of the answers, just put it in the chat, and then I'll let you know if you got it. So I'll just stand by here. I'll let you guys kind of work through that. You should only take about 10 minutes. Shouldn't take too long. If you're stuck, let me know. Also, just send me a chat if you're stuck on any parts. But I kind of gave you hints for each of those. Okay, sorry, just tackling an email there. So someone's sharing some answers. Thank you, Sarah, for sharing some of your answers. Let me actually pull up the answer key. Hold on a sec. Yeah, Sarah, you got part A. Good work, Sarah. And you definitely got part B. So I'll share Sarah's answers just a little bit. And I'll chat with you privately if you're sharing answers with me. And Sarah, I know you shared part C. Let me see if you got your part C right. You did good work, Sarah. You got part C right. Okay. So let me start sharing some answers. So for G of 4, remember starting at 1 and going towards 4. Actually, if you notice, these areas will cancel out. Let me do this in actually 4 regions here. So we have region 1, 2, 3, I can call this like A1. I'll call this A2, A3, and A4. Well, I know A3 and A4 are going to cancel out, so I can just knock that out. A1 is a base of 1, height of 2, so that's 1, because 1/2 times base times height, and that's also 1 as well. So if you integrate from 1 to 4, you just get 2. So G of 4 is going to equal 2, just so you know. So G of 4 equals 2. If you do integrate from 1 to -2, so if you want G of -2, you're integrating from 1 to -2, as I show you down here. So you got to reverse the order, make sure the lower limit, so that way you're going from left to right. So you got to reverse the order of integration to go from -2 to 1, but you got to put a negative out in front. And yes, that's -2, sorry, that's -2 to 1. So yes, from -2 to 1, that's positive area. That's 3 and 2. Sorry, 3 and 3. So that area is 4.5. But because we reversed the order of integration from the get-go, because it wasn't from -2 to 1 originally, it was from 1 to -2. So you have to make it -4.5. That's the reason why. So G of -2 is -4.5. So again, if I told you if I'm an integral from -2 to 1, of course you say 4.5. But if you reverse it, well, then you got to put a negative, right? And then instantaneous rate of change, G prime of 2 is F of 2. F of 2, of course, is 1. So there we go. Find the absolute minimum value of G on the closed interval. So if we already know G of -2 is 0, because the limits are, sorry, G of -2, sorry, we did it earlier, that was -4.5, my bad. That was -4.5. And G of 4, we found that was 2. My critical point is when F, when G prime is 0, F is 0. F is 0 only right here, and here also, we already included that. So you got to put 3. So you also integrate from 1 to 3. If you integrate from 1 to 3, that's going to be, let's see, from 1 to 2 is 2, and that's 0.5. So you get 2.5. So your lowest obviously is going to be right there. That's going to be your absolute min of -4.5, x equals -2. And then the last part, There's a point of inflection at x equals 1, yes. You have point of inflection at x equals 1 because, and actually I could probably, well, I'll share more. I'll probably put some test review materials like these solutions here. But at x equals 1, f prime is positive here, f prime is negative here. Remember, g dou prime equals f prime, right? And you want the second derivative, you want a point of inflection, so you want g dou prime to change sign or f prime to change sign. So that's what's happening there. So you have a chance to do more practice. Number 57 of the homework will be more opportunity to practice. Do you have the solutions so you can check your work too? I believe it should line up with the work there. Yeah, let me just double check that it matches up with the old edition. Then I just want to briefly talk about 7.1, then we'll end class for today. Yeah, they line up just fine. So, okay, cool. So let's briefly talk about 7.1. So I'll keep this recording going. Actually, I'll just do as a new recording. So we'll have 3 recordings here. Stop sharing.